This is section 9.4, part A, polar forms of conic sections. Previously defined conic sections in terms of the distance between the focus and directrix for a parabola, or between foci for ellipses and hyperbolas. Alternatively, we defined all of those curves using the focus directrix definition of a parabola. In general, a conic section can be defined as the locus of points such that the distance from points P to the focus and the distance from the point to the directrix is a constant ratio. This constant ratio, PF over PQ, represents the eccentricity of a conic, is denoted with the letter E. So if we look at our different conics, if the eccentricity is between 0 and 1, it'll be an ellipse. If the eccentricity is exactly 1, it will be a parabola. And if the eccentricity is greater than 1, it will be a hyperbola. The conic sections with eccentricity of E is greater than 0 and D is greater than 0, and a focus at the pole of the polar equation will be in the following forms. So we can have R is equal to E times D over 1 plus or minus E times cosine of theta, or it can be 1 plus or minus E sine of theta. If it is cosine, then our directrix will be a vertical line x equals D or negative D. And if it has sine on the bottom, then our directrix will be y equals D or y equals negative D. To analyze the polar equation of the conic, begin by writing the equation in standard form. So we want to have it in the form where we have E times D over 1 plus or minus E times either cosine or sine. From here, we're going to determine the eccentricity and use this value to identify the type of conic equation that it represents. Then determine the equation of the directrix and use it to describe the orientation of the conic. So we need to determine the eccentricity, the type of conic, and the equation of the directrix. So the first thing we need to do is get this in the correct form. Now, it's always going to be 1 plus or minus some value. So the first thing we need to do is we need to factor out this 3. So if we factor a 3 out of the denominator, 3 divided by 3 gives me 1. 2.25 divided by 3 is 0.75. Now we need to simplify this. 3 goes into itself once, 3 goes into 9 3 times. So in standard form, we're going to have 3 over 1 plus 0.75 cosine of theta. Now, an equation in this form will be R is equal to E times D over 1 plus E cosine of theta. And if it's in that form, we know that the directrix will be X is equal to D. Now, if you notice in this form, the eccentricity, or the E value, is whatever is right in front of the cosine. So we know that our eccentricity of this conic section will be 0.75. And if we look at that previous slide, if the eccentricity is 0.75, that means it's falling between 0 and 1, so that means this will be an ellipse. Now we know that the numerator is E times D. So we know that E times D is equal to 3. We already know that our eccentricity is 0.75. So to get the D value by itself, we would divide both sides by 0.75. And then we will get that D is equal to 4. We already know that our directrix for this type of equation will be X is equal to D, or in this case, it will be X is equal to 4. Again, we're going to determine the eccentricity, the type of conic, and the equation of the directrix. So first we need to notice that this is the sine part comes first, so we're going to rearrange this. So it's going to be negative 16 over negative 2 plus 4 sine of theta. We also know that the number out front in the denominator should be a 1. So to make that a 1, we're going to factor out a negative 2. So if I factor out a negative 2, it's going to leave me with 1. 4 divided by negative 2 gives me a negative 2 sine of theta. Now we do need to simplify. Negative 2 goes into itself 1 time. Negative 2 goes into negative 16 8 times. So the equation is going to be 8 over 1 minus 2 sine of theta. Now that means our equation is in the form of e times d over 1 minus e sine of theta, and it means that our directrix for this equation will be in the form of y equals negative d. We know it's y because it's sine, and because this is minus, it means it's going to be a negative d. So let's identify what we know. The value in front of the sine is your e, or your eccentricity. So we know that e is equal to 2. Because the e value is greater than 1, we know this is a hyperbola. Now we know that e times d is equal to your numerator. So we know that e times d is equal to 8. We already know that our eccentricity is 2. So if we solve for d, we're going to get 4. And we know that our directrix is going to be in the form of y equals negative d. Now we need to write a polar equation and directrix for a conic section given this information. So if our directrix is in the form of y equals 4, if we look back at our equations, if our directrix is y equals a positive value, then we know our equation is going to be in this form. So we know that r is going to equal e times d over 1 plus e sine of theta. So e times d, we know this is y equals d, so we know our d value is 4. So we know 2 times 4 over 1 plus 2 sine of theta, or 8 over 1 plus 2 sine of theta would be the equation for our conic section. Write a polar equation and directrix for the conic with the given characteristics. Now, we know that because our eccentricity is between 0 and 1, that this conic section is going to be an ellipse. We know where 2 vertices are on this ellipse, so we can find the center by finding the midpoint. So if we use the midpoint formula, negative 4 plus 12 over 2 and 0 plus 0 over 2 will tell us that our center is going to be at 4 and 0. Since the center is to the right of the pole when we're in polar coordinates, the directrix has to be to the left of the pole. So if our center was to the left, our directrix would be to the right. So since our directrix is to the left, we do know that our directrix will be negative. So it's either going to be x equals a negative d, or it's going to be y equals a negative d. Since the x's change for our vertices and the y's are staying the same, we do know that our directrix will be in the form of x equals, and then we already said since the center is to the right of the pole, the directrix will be to the left, so it's going to be x equals negative d. And since we know that our directrix is x equals, then we know that our equation will be in the form of e times d over 1, since this is a negative d, this will be a minus e, because it's an x, we know it's cosine of theta. Now we're going to use e and the polar form of one of our points to find the d value for our equation. So we're going to take, because our center is to the right of the pole, we are going to take a point that is to the right of the pole, and we're going to write this rectangular point into polar form. Remember, to break this into polar form, we need to find the r value, and r value is x squared plus y squared. So we're going to do 12 squared plus 0 squared, or square root of 144, which is just 12. To find our theta, it's going to be the inverse tangent of y over x. Now we picked the positive one because it's to the right, but remember, if we would have picked the negative one, when you're finding the inverse tangent, because that x is negative, we would have had to add 180 degrees if we were going in degrees, or we would have had to add pi if we were in radians to our equation there. So this would be inverse tangent of 0 over 12, or theta in this case is just going to be 0 degrees. So our point will be, our r value is 12, our theta is 0, and we're going to plug everything we know into the equation and solve for d. So if we're substituting into this equation, we know the r value is 12. We know that e is 0.5, but we don't know the d value. That's what we're solving for. And we're going to do 1 minus e times the cosine of 0. Now, if we do 1 minus 0.5 times the cosine of 0. Cosine of 0 is just 1. So this would be 0.0 minus 0.5, because 1 times 0.5 is just 0.5. 1 minus 0.5 is 0.5. We have the same number on the top and the bottom. If not, we could multiply both sides by 0.5 to get out of the denominator, and then divide to get the d by itself. But because these are the same, we can't just cancel them, and we're going to find that the value of d is equal to 12. So if we want to write the equation, we can do e times d over 1 minus e times the cosine of theta, or 6 over 1 minus 0.5 cosine of theta would be the equation in polar form of our conic.